Hi future doctors, welcome to the next class. In this class, we will see some problems on properties of solids means Young's modulus regarding that elongation. A wire of length L. So whenever you are suspending some load on this M1, tension developed in the string is T1. Whenever T1 its total length, they will give L1, including elongation. So it will be elongated. Let us assume like this. Its length is L1 at a T1, they will say. Next, they removed this. They have suspended another one M2. At the time, its length is L2. So for T2, it is going to be L2. What is the original length? They are going to ask. At the time, what we will do means elongation is equal to FL by AY. So whenever they are suspending load, area of cross section same y. So y is same material. Initial length also same, that is here. Now what is different means elongation is different, L1 and L2 final lengths, and applied force is different. Therefore, elongation is directly proportional to applied force. What is the elongation? So whenever T1 apply, total length is L1, initial length is L. Therefore, this is the elongation. So what is the elongation means? L1 minus L is directly proportional to T1. So for second case, L2 minus L is directly proportional to T2. So if you divide these two, so L1 minus L by L2 minus L is equal to T1 by T2. From here, this is mathematical calculation to find the initial length. T2 into L1 minus L, T1 into L2 minus L. We want L. T2 L1 minus T2 L. So T1 L2 minus T1 L. So T2 L1 minus T1 L2. So this one we brought left side. Next T2L minus T1L. So if you take common L, T2 minus T1. Here T2L1 minus T1L2. Therefore, final length of the wire is going to be T2L1 minus T1L2 by T2 minus T1. In this, which is highest tensional force means T2, isn't it? Therefore, T2 minus T1. So with T2 term, you have to start. It will be coming easily. So how they will give means for 10 newtons force or 5 newtons force. 5 newtons force length is 5 meters. For 10 newton force, its length is 15 or 10 meters they will give. So what is the original length they will ask. At the time directly you can substitute if you remember this formula. Next, what is the Young's modulus? What is the Young's modulus, bulk modulus of rigid body they will ask. Rigid body. So what is meant by rigid body means here? So even though you apply deforming force, it is not changing its original size and shape. So now I am applying some amount of force on this to fold or some amount of force on this marker to fold. It is not able to fold. But if I am applying force on book, so on book we can apply the force, it is going to change its original size and shape. If it is changing its size and shape like this is nothing but not rigid body. So if it is not changing its size and shape, that is rigid body. If it is not changing size and shape, what is the Young's modulus means? Y is equal to FL by EY. So not changing size and shape means elongation is 0. Anything by 0 is nothing but Young's modulus is infinity. Bulk modulus. What is bulk modulus formula? PV by delta V. So delta V, there is no change in volume. Therefore, this is also 0. Bulk modulus also infinity. What is the compressibility they will ask? Compressibility is reciprocal of bulk modulus. That is going to be 0. So like this, they will ask some questions on elongation or Young's modulus. Still will be there. We will discuss in problems case after completion of the syllabus. We'll see. Next, two different wires. L1, area of cross section A, Y1. It is made up of iron, let us assume. another wire L2, Y2, same area of cross section. I have suspended some amount of load on this mass. Now, what is the resultant Young's modulus, they will ask. Now, what is the total length now? L1 plus L2. Area of cross section A. So, resultant Young's modulus Ys. Then, how we are going to get means load or weight is going to be acting. First, we will take this load for this wire. Which wire? For the above wire. At the time, singly, if you have seen this, elongation within this is going to be E1. Like that, only this wire if you are taking, red color wire, elongation in this is E2. Therefore, total elongation within this is going to be E is equal to E1 plus E2. Now, what is E formula? FL by AY. Therefore, E1 is going to be same weight mg L1 by A by 1. So, E2 mg L2 by A by 2. Then total elongation E. So, for this E is equal to same mg. So, total length is now L1 plus L2 divided by A by S. So, if we substitute here mg L1 plus L2 by A by S is equal to mg L1 by A by 1 plus mg L2 by A by 2. So, mg by A if you cancel among all, then final one is L1 plus L2 by Ys is equal to L1 by Y1 plus L2 by Y2. If the lengths also same, means L1 is going to be L2 is going to be L. At the time, 2L by Ys is equal to L by Y1 plus L by Y2. Therefore, if we solve this, Ys is equal to 2Y1 Y2 by Y1 plus Y2. Average velocity formula we have in motion in a straight line. 2V1 V2 by V1 plus V2. This formula you will apply whenever distance is same. This formula you will apply whenever load is going to be seen. Same like that if you connect those two in parallel. Two wires connected in parallel like this. So, Y1, Y2. Same length, same area you can take. Then, YB is equal to Y1 plus Y2 by 2. Important formula and easily you can remember. I hope you people understood these problems and resultant Young's modulus whenever two wires connected in series and parallel. Okay.